For decades, scientists have searched for another Earth, not simply another planet, another world, capable of supporting life. They have discovered frozen worlds, burning worlds, ocean planets, and planets so massive that a human standing on their surface might barely be able to move. But finding a planet at the right distance from its star is not enough. Mars lies near the habitable zone, yet its surface is a frozen desert. Venus is almost the same size as Earth, yet its atmosphere transformed the planet into an inferno. The difference between a living world and a dead one may come down to a single thing: an atmosphere. And now, 48 light years away, scientists may have detected one around a rocky world where liquid water could exist. Its name is LHS 1140b, and what researchers saw escaping from this planet should not still be there. LHS 1140b was discovered in 2017. It circles a small, dim red dwarf star far cooler and smaller than our Sun. The planet completes an entire orbit in only 24.7 Earth days. But despite being extremely close to its star, it receives relatively little energy. The star is simply too faint. That places the planet inside the habitable zone, the region where temperatures might allow liquid water to survive. LHS 1140b is approximately 1.7 times wider than Earth and around 5.6 times more massive. It belongs to a class of planets known as super-Earths, worlds larger than Earth, but smaller than ice giants like Neptune. From the moment scientists discovered it, the planet looked promising. It appeared large enough to hold an atmosphere. Its stars seemed calmer than many other red dwarfs. Some models even suggested that the planet could contain enormous amounts of water. But there was one major problem. Nobody knew whether it still had an atmosphere. Red dwarf stars are everywhere. In fact, they are the most common type of star in our galaxy. That should make their planets excellent places to search for life. But there is a problem. Young red dwarfs can be incredibly violent. They produce intense ultraviolet radiation and powerful stellar flares over billions of years. This radiation can tear gases away from nearby planets, slowly stripping their atmospheres into space. A world might begin with oceans, clouds, and a thick protective sky, only to end as an exposed rock. This may have happened to several rocky planets already examined by the James Webb Space Telescope. Scientists began to wonder, can small planets around red dwarfs hold atmospheres at all? Then, researchers examined LHS 1140b. In 2024, the planet passed directly in front of its star. Scientists observed this transit using the Magellan Clay Telescope in Chile. At such an enormous distance, the planet cannot normally be seen directly. Instead, scientists study the light of its star. As a planet crosses in front of that star, a tiny amount of starlight passes through the gases surrounding it. Different gases absorb different wavelengths of light. They leave fingerprints hidden inside the spectrum. And inside the light from LHS 1140, scientists found something: helium. It appeared to be escaping from the planet and drifting into space. But when scientists observed another transit in 2025, the signal was gone. Was the original detection simply a mistake? The researchers tested possible interference from Earth's atmosphere. They compared the result with another planet in the same system, and their conclusion was far more interesting. The escape of helium may change over time. Scientists may have captured LHS 1140b during a temporary atmospheric event, almost like watching a distant world. Exhale. And that creates a mystery. Helium is extremely light. Once it reaches the upper atmosphere, radiation from the star can give it enough energy to escape. LHS 1140b is billions of years old. If the planet possessed only a small temporary collection of helium, that helium should have disappeared long ago. But it is still there. Why? The answer may be hidden, much deeper inside the planet's atmosphere. More helium could be moving upward from a massive reservoir below. The planet's upper atmosphere may be dominated by helium, while heavier substances remain trapped closer to the surface. Those deeper layers might contain carbon dioxide, they might contain water vapor, or perhaps LHS 1140b is an enormous water-rich world, a planet covered by a vast ocean, hidden beneath a dense atmosphere. But this is where we must separate evidence from imagination. Scientists have not discovered oceans, they have not detected oxygen, and they have not found life. Helium does not mean that humans could breathe there. It does not mean that anything could survive there. What scientists discovered is something more basic, but incredibly important. Evidence that a potentially habitable rocky world may have protected its atmosphere for billions of years. But LHS 1140b matters far beyond a single planetary system. Red dwarfs make up most of the stars in the Milky Way. If rocky planets around these stars can preserve their atmospheres, then the number of environments capable of supporting liquid water could be far greater than we believed. That would not prove that life is common, but it could mean that Earth is not the only place where the necessary conditions can survive. We have not discovered a second Earth. We have not discovered aliens, but we may have discovered a world that protected its atmosphere through billions of years of radiation, a world that refused to become a silent, exposed rock. 48 light-years away, helium is slowly drifting from LHS 1140b into space. It is not a message. It is not proof of life. But it may be the first sign that this distant world still possesses something Earth had, long before any creature opened its eyes: a sky. Now, the James Webb Space Telescope will investigate further. A new observing program plans to study 9 eclipses of LHS 1140b. When the planet moves behind its star, Webb will measure an incredibly small change in infrared light. That change can reveal the temperature of the planet's day side. If LHS 1140b is only a bare rock, the side facing its star should become extremely hot. There would be no atmosphere to carry that heat around the planet. But if heat is moving from the illuminated side toward the dark side, that would provide additional evidence of a substantial atmosphere. Scientists will also search for possible signs of carbon dioxide. At the same time, Hubble will measure the ultraviolet activity of the planet's star. It may take several years to discover what this world truly is: an airless rock, a dense mini-Neptune, a massive ocean world, or something completely unexpected. But the search has already changed. Scientists are no longer asking only whether a planet exists there. Now, they are asking a far more interesting question: what is its sky made of?